So think of a standard HDMI cable, like a short garden hose, right?
Right? Yeah.
It works great in your living room when the spigot is, right next to the TV.
Right.
But how do you get that exact same water pressure 6 miles away?
You really have to ditch the hose entirely and just use glass.
Exactly. So today we are doing a deep dive into a product page from HDTVSupply for a device with a seriously massive name. It is the Javelin FXT-460-TX 4K HDMI 2.0 Fiber Optic Extender Sender.
Yeah. And our mission for this deep dive is to decode the, frankly, extreme engineering required to push all that ultra-high definition data across mind-boggling distances.
Without dropping a single pixel, hopefully.
Right, exactly. No dropped pixels.
Yeah.
We're talking about moving from your standard home setup into, like, industrial scale AV.
Okay, so let's unpack this. Because to understand why a device like the Javelin is even necessary, you have to look at the sheer weight of 4K data.
Oh, it's an avalanche.
Yeah, it's not just a steady stream.
No, I mean, when you're running true 4K video at 60 hertz with HDR.
That's high dynamic range, right?
Yeah, exactly. When you do that, you are demanding 18.2 gigabits of bandwidth every single second.
Which is just a staggering amount of data.
It is, and standard copper wires just physically choke on that much electrical data over long distances.
Yeah.
The signal degrades, you get screen flickering or just complete dropouts.
So the Javelin solves this by converting that massive electrical signal into pulses of light, sending it over a single strand of LC-terminated fiber optic cable.
Right.
But I have to admit, I got a little confused here. The specs say this can push uncompressed video up to 1,000 feet on, quote, multi-mode fiber.
Right.
But then it said they can do 10 kilometers, which is roughly 6 miles on single-mode fiber. What does the mode actually mean here?
So it really comes down to the width of the glass core inside the cable. Multi-mode fiber has a wider core.
Okay.
And because it's wider, the light rays actually bounce off the walls as they travel. Over long distances, those bouncing rays scatter and lose their timing.
So the signal degrades.
Exactly. But single-mode fiber has a microscopically narrow core.
Oh, so it can't bounce.
Right. The light shoots straight down the middle like a laser. That's why it maintains perfect signal integrity for 6 miles.
That makes physical sense, sure. But I have to push back here. I mean, who on earth actually needs to send a TV signal 6 miles down the road?
Well, what's fascinating here is that you have to zoom out, right? Think about sprawling commercial environments.
Like what?
Like a massive university campus or an NFL stadium, or even, HDTVSupply's enormous sports bar systems that run like up to 160 TVs simultaneously.
Oh, wow.
Yeah, in those spaces, the centralized server room might literally be in another zip code from the displays. Copper wiring is just completely useless there.
But wait, sending a perfect 4K picture 6 miles is basically useless if I can't sync the sound or, control the screen when it gets there?
Exactly. Pushing the pixels is really only half the battle.
Because the spec sheet throws around alphabet soup like EDID management and bi-directional RS-232. What do those actually do?
Think of them as translators and traffic cops. They let the video source and the actual TV display seamlessly talk to each other.
Even miles apart.
Yeah, they negotiate screen resolutions and power commands instantly. And for sound, the Javelin uses something called HDMI audio bridging.
Okay, let me try an analogy to see if I'm visualizing this right.
Sure, go for it.
So imagine the massive 4K data stream is a multi-lane highway, right?
Yeah.
And the video signal takes up 4 lanes of traffic.
Okay.
Does audio bridging essentially let you broadcast a totally different radio station in the carpool lane without disrupting the rest of the traffic?
That actually captures the mechanism perfectly. You can inject a completely separate audio signal into that fiber optic stream.
Oh, cool.
Yeah, using either a standard 3.5 millimeter analog cable or a TOSLINK digital optical cable.
Wow.
And the Javelin can even generate a completely blank HDMI output.
Wait, like no video traffic at all?
Right, no video, just to carry a dedicated audio network. And the kicker is it's doing all of this commercial-grade routing for $347.35.
Which really highlights the intense markup we often see on everyday consumer electronics.
Oh, absolutely.
So if stadiums and commercial spaces are already abandoning copper for fiber to handle these heavy data loads, how long until the standard HDMI cord behind my couch becomes completely obsolete?
Well, we are rapidly approaching the physical limits of what copper wiring can handle.
Right.
Understanding how fiber optics obliterate standard bandwidth bottlenecks, it really shows you the exact trajectory of consumer technology. We will have to transition to light.
Because the digital pipeline just isn't big enough anymore.
Exactly.
Which leaves you, the listener, with
Really?
this to consider. If we can already perfectly transmit 18.2 gigabits of data per second over a 6-mile thread of glass today,
Yeah.
what happens to our physical world, our streets and our homes, when our everyday personal devices demand this exact same infrastructure just to function?